everyone, welcome back to my channel. In this problem, I'll show you how we can prove that sec theta minus sin theta is equal to tan squared theta plus cos squared theta over sec theta plus sin theta. So the strategy here is that how do we transform this to that? And so the idea is that first of all, look at the left hand side. And by the way, if you're new here, please consider subscribing and always leave a comment. So we look at the left hand side and then the right hand side, but we observe that on the left hand side the function is sec theta minus sin theta, and on the right hand side in the denominator we have like a conjugate to that. Okay, with same functions but with a positive sign in the middle. So that gives us an idea on how to start with this verification. So what you're going to do is to be creative enough, multiply and up and down by the kind of the conjugate of this, and so that means we are going to have like sec of theta minus sine of theta. So I'm going to divide by the same expression but with a changed sign, because now I'm looking at the right hand side and I need to come up with this one. So that is why we are playing that trick. And so this is going to be sec theta plus sine of theta. This is what you have introduced in. So that means that we need to make sure that we eliminate it, and so that is by multiplying it again up and down. So in other words, plus theta. So this is what you have. So this is the new term. It can cancel and then we go back to that. So we can see that when you get to this level, this top part is like a difference of two squares. And if you remember, if you have a squared minus b squared, this is the same as a minus b into a plus b. And so we can make a use of this condensing of the two brackets back to this part. And so the top part is going to give me sec squared of theta. This is minus sine squared of theta. And so this is over now sec of theta plus sine of theta. So when we get here, we are getting closer and closer. We can see that the denominator is the same as what we need down here, but then the upper part is slightly different. So what are we going to do? What you're going to do here in this case is to just to modify these expressions. And how do we do that? We are going to make a use of trigonometric functions or trigonometric identities. And so we are going to just begin from we can observe that we have sine here, and then in the wanted expression we have cos. So we can just begin from sine squared theta plus cos squared theta being equal to 1. And so that means our sine squared of theta can be the same as 1 minus cosine squared of theta. This is 1, so we can keep it right here. And then also we can recall that when we divide this expression, the identity here by throughout by cos squared theta, we can get tan here 1 and then 1 over cos squared, which is sec. So in other words, we get expression like tan squared theta plus 1, and this is equal to sec squared of theta. And so what does that mean? It simply means that I can then now come and grab this and substitute it for sec squared, because I'm looking at transforming this into in terms of tan and then cosine. And so this means that now from here, if you substitute for sec squared theta with this, it will give us tan squared of theta plus 1, then take off sine squared, but sine squared is already here, and so that means we have 1 minus cosine cos squared of theta. And so this entire expression is over sec of theta plus sine of theta. And so if we try to open up the brackets, we can see that this is minus 1, which is going to cancel that, and then minus minus, that goes to positive. And so then we can say that sec theta minus sine of theta is equal to tan squared of theta plus cos squared of theta, everything over sec of theta plus sine theta. So as easy as this, so we can prove all these identities very easy if at all we are creative enough, and then also focus on what we want to come up with. Okay, thank you for watching. Please consider subscribing if you are new here, and then also you can leave a comment and how you feel this is helping you.